Favorites.
Good afternoon, all of you. Today I am going to discuss Introduction to Classification. My name is Moumita Ghosh. I am working as Assistant Professor in the Department of Information Technology, Haldia Institute of Technology. So, what is classification problem? Classification is a supervised machine learning algorithm where we can predict the current level of given input data. In the classification, the model is fully trained using the training data, and then it is evaluated on the test data before being used to perform prediction or on new unseen data. Suppose this is a one snippet of a data set. Now where I can see that this is my target variable. Now, what do you mean by target variable? Target variable is nothing but my class. Here we can see that we have two classes, 0 and 1. That means this is a binary class classification problem. We will come to that point later. Before that, we would like to know what is the typical scenario of a classification problem. Now, in a classification problem, we will have some label and as well as we will have some features. Now, using these features, we have to train the model, and then in the testing we have to evaluate the target variable, and we have to predict the target variable. Now, next, suppose in this scenario we have to predict. This is a one example. We have to predict that whether a message is a spam message or it is a normal message. Now, for that, this is our classification. Let's assume this is our classification model. It is built using some XYZ algorithm. I will come to the algorithm part later on. Before that, now this classification model is at first trained using some training data set. Now, which is comes here using this training data set, the model is trained, and the model is as well as after training, the model is validated. And after the validation, whenever some new messages are coming, these new messages are predicted through the classification model, and the classes are decided whether one message, the incoming message, is a spam message or it is a normal message. Now, this is a example of a classification problem. Now, next slide, we will see that two types of learners are generally present in the classification problem. One is a lazy learner, another one is the eager learner. Now, what is the basic difference between these two? Now, eager learners are the machine learning algorithms that first build the model from the training data set before predict anything. That means it will take some time to train the model in the training process. Because of their eagerness to have get a better prediction whenever they will do the prediction, then obviously in this type of model will do the better prediction. So for that reason it will take a more time in the whenever it will train the model, and whenever and it will take some less time whenever it will make the prediction. What does it mean? That means the eager learners are the eager learners are the process that where the it will build the model at first, and then it will predict the new instances. Now, corresponding or opposite to the now these three are the algorithms of the generally used in the eager learners. Now, these are the logistic regression, support vector machine, and the decision tree. These three are the widely used. There are many more algorithms are there, but these three are the widely used algorithms for the eager learners. Now, contrast to the eager learners, in the case of lazy learners, it will not build such model, or it will not create any model. Actually, it will try to start the predict immediately. Now, how it will be predicting? Now, it will memorize the training here as it is written. It will memorize the training data, and each time there is a need to make a prediction, they search for the nearest neighbor from the whole training data. That means what they will do, now in a data set, it will see the which which instance is closest to that particular instance. If these two instances are very close due to some criteria, then they will predict that new instance as a nearest instance. This is the basic criteria of a lazy learners. Now, K nearest neighbor is a widely used example of the lazy learners. Now, next. These are the some examples or where we can widely use the machine learning classification algorithm in the real life in the healthcare. Suppose we would like to predict any disease, or suppose we have some historical data we have, and using this historical data we would like to categorize some disease, or we would like to predict some disease. In this scenario, we can use the classification algorithm. As well as it is nowadays widely used in the educational field, in the transportation agriculture field, and as well as the sustainable agriculture field. So our next concern is that which kind of problems is actually solved by the classification task. Now, generally there are two types of classification problem. Now, one is binary class classification and another one is the multi-class classification. Here I should write here binary class classification. And this is the multi-class classification. Now, in the binary class classification, that means here I have two classes. Here I can see from this example, I have one class as truck and another class as a boat. Now, using this machine learning model, that means as this is the classification problem, whatever the data set is corresponds to this particular set, that will be earlier trained, and then whenever we are just predicting, we have to predict in between these two class instances. That means here the target variable has two values, or target variables is either truck and another one is the boat. Now, if the same problem is solved by the multi-class classification, then we have more than two classes. At least we have more than two classes. Now, here we have the three classes. Now, using the three classes, whenever our prediction work will be done, or our classification work will be done, then we will call as the multi-class classification problem. Now, another one classification, criteria or feature of a classification problem is the imbalance classification. Now, what do you mean by imbalance classification? What do you mean by balance? Balance means all the class variables has equal number of instances in the data set, and in the case of imbalance, that means all the category of the variables are not having the equal number of instances. That means all the classes are not having the equal number of instances in the dataset. Suppose let's take an example of the distribution of the percentage of different instances of different classes. Here we have three classes, as we can see. One is the truck, another one is the planes, another one is the boats. That means suppose 60% instances are belongs to the truck class, and here 25% instances are belong to the plane class, and another 15% belongs to the boat class. That means here we don't have the equal number of the classes. Now, if this would have been a balanced problem, then what would happen? Suppose 33.33% of the instances are present in all the classes. That would have been a balanced problem. Now, next. Now, there are several metrics which we would like to know that will measure or evaluate any classification task or any classification algorithms. Now we have seen earlier some of the algorithms, means we have just only name, and we will discuss the algorithms in the later on classes, in the new classes. But before that, these are the matrices which are used to evaluate any classification algorithm, and these are the important, these all are the important. We will discuss one by one all this. Now first one is the confusion matrix. Now what is confusion matrix? Now suppose this is our scenario. Now what is the typical scenario? That suppose the task is to predict whether a patient is having the heart disease or not. Heart disease is a two class or the binary class problem. That means one person may have the heart disease or one person may not having the heart disease. That means this is the binary class problem. And this is the binary class classification problem where the model will predict 1, that means 2, that means yes, the patient is having the heart disease, and 0, that means the false, that means the patient is not having the heart disease. Now this is the typical confusion matrix for the binary class problem. Now where in this side we have the predicted values and this side we have the actual values. Now what do you mean by this? That means TP, that means what is TP is nothing but true positive. That means we have predicted the value as true, and as well the actual value is also the true. Now if we see the definition, it is written over here that when the actual value is positive and the predicted value is also positive. Now this class belongs to the true positive, where the actual as well as the predicted values both are positive. Now second one is the true negative. Now what do you mean by true negative? When the actual value is negative and as well as the predicted value is also negative. Now this is the TN. And next we have the false positive. Now what do you mean by false positive? False positive means when the actual value is negative but the prediction is positive. This is nothing but the false positive. Here we can see that actual value is, here we can see the actual value is negative, but we have predicted as a positive. That's why it is nothing but the false positive, as we have predicted is it as a false. Now next we have the false negative. Now what is false negative? When the actual is positive but the prediction is negative. Now we have another two types of error. This error is called type 1 error. This error is called the type 2 error. So next we are coming to this portion. Before that, we have to measure. Next parameter is our accuracy. Now in the accuracy, accuracy simply means how often accuracy. Accuracy simply measure how often the classifier makes the correct prediction. It is the ratio between the number of correct prediction and the total number of prediction. That means what? Suppose in this category we have any 6 instances are here. Here is 1, here is 2 and here is the 11. That means what? That means we have the actual positive value 2 and we have the predicted these 6 as a true value. That means the accuracy is nothing but TP plus TN by TP plus TN plus FP plus FN. What do you mean by that? That means how many values we have treated as a positive by total number of observation. Here how many number of correct prediction? Correct prediction is 6 plus 11. That means the all true positive as well as all true negative. That's why it is written as 6 plus 11. And how many total observations are there or correct predictions are, total number of predictions are there? There are 6 plus 11 plus 2 plus 1. So this is nothing but our accuracy. Next we have the now, if we consider this thing using this example, that we have this actual value we have the problem is that we have 20 dogs and 20 cats, and we have to predict whether it is a cat or not. So we can see that from the earlier example that here we will have the cat and we are getting as a cat. So our intention or our target is to predict whether this is a cat or not. That's why here, yes, this is our actual value is cat and we have predicted it as a cat. Here also our actual value was cat and we have predicted the cat as a cat. Similarly here, and here is one instance, here is one instance, here is one instance, and here is the one. That means total we have the 6 cases where we can found that we have the 6 number of cats where belongs to actually cat was where actually cat, and we have predicted all 6 cats as a cat. That's why this is our nothing but true positive. That's why it is written in this particular cell. That's 6. The value is 6. Now next we have true negative. That means what is the definition of the true negative? As we know that true negative means when the actual value is negative and the prediction is also negative. Let's see from this example, actual value is negative and the predicted value is also negative. Let's see. Suppose dog. So in our case, as our target is to find out whether it is cat or not, then our target is to find out which are the not cat. So actually in this is dog and we have predicted as a dog. Here 1 case, here 2 case, here 3, 4, I can see 5, 6, 7, 8, 9, 10 and 11. So here we have total 11 cases where we will find as a true negative. So that's why here 11 is mentioned. Now another 2 category which is false negative and false positive. Now case for the false negative. Now what is the definition of the false negative? Now in the false negative, now here we can see that where dog is our class and we have predicted as a cat, and here also dog is our original class and we have predicted as a cat. That's why in the false positive we have written the value as a true. That means in the false positive, that means the predicted values is positive and whereas the actual value is negative. That means we have predicted it as a cat but originally it was my dog. Now how to calculate the recall? Now it is a measure of actual observation which are predicted correctly and how many observations of positive class are actually predicted as positive. It is known as the sensitivity. Recall is a valid choice or evaluation matrix when we want to capture as many as positive as possible. Now, predictions are actually positive. That means actually they were cat and we have predicted as our model has predicted as a cat. And how many such values are there? We have such 6 values are there. And how many total predictions actually positive values are there? Actually positive values means this 6 plus 1. That's why it is written 6 over here, and in the numerator and the denominator we have the 6 plus 1. So we have the 0.85. And if we calculate the precision, what we will get, what is the definition of the precision? Prediction actually positive by total predicted positive. Now if we consider this column as this is the predicted values, so we will get the total number of positive as predicted. The number is 6 plus 2. That's why it is written here 6 plus 2. And how many numbers are truly positive? That means the true positive. This is the 6. That's why the value is 6 by 6 plus 2. In the numerator, we will write 6 and the denominator, we will write 6 plus 2 and we will get as a 0.75. Already I have discussed the recall, and next one is the F1 measure. Now, what is the means in the F1 measure? It will give a score in between 0 and 1. Actually, the F1 measure will take the harmonic mean. It will not take the simple average, as the simple average is sensitive to the very low or very high values. That's why we have taken the F1 measure. So F1 score, and the F1 score of this problem is 2 into recall into precision by recall plus precision, and we will have this. That means if once F1 measure is good, that means my model is good enough. So today that's all for today's class, and in the next class we will be discussing one by one all the algorithms, and we will be whenever we will be discussing the algorithms, then we will be thinking and we will be starting then why the evaluation matrix and what should be the ideal value of any evaluation metric. So thank you all of you.